it's recording.
All right, Kevin, thank you for coming in to interview today, man. Appreciate it. Even though you just interviewed me, so I'll interview you now. So today we're going to be discussing a reverse linked list. I'm just going to read the prompt here, and then get you to walk me through your thought process and hopefully solution of the problem. So we're looking at a reverse linked list, and your prompt is to write a function, reverse linked list, that receives the linked list node as input and then reverses the list starting from the given node. Do this in place without using any extra memory. Your function should return the value of the head of the list. Here is a simple linked list class. And then you're given, do you have the prompt? Do you have the prompt?
Yeah, I'm looking it up right now.
Yep, and then you're just given two versions, one in JavaScript, one in Swift, and obviously we're looking at the Swift, the JavaScript version, and it just explains a class of list node, constructor value inside of that, and then key value pairs within the constructor value.
Okay, so yeah, so what my definition of a linked list, or as I understand. Yeah, let me erase this. Oh, not working. So linked list, from what I understand, it's like you have the bunch of values similar to an array, but you only start off from the head, and then the head links up to the next value. This arrow right here is to represent this dot next part of the constructor class we have here. So each arrow is a next. So it's just an example I'm going to use. So this is a regular linked list. The head is at 1. That's the first value. And then points next to 2. That's how you know it's the next value. And then 2, next is 3. So if I ask what is the next of 2, it's going to give me 3. But if I try to ask what's 2 relation to 4 or 5, there's no way to skip over like that. You can only look at each value at currently what it is and what's the next value. That's how it's a linked list. And it's a very basic data structure, but it can be useful. So I want to reverse it. So it's a reverse linked list. And this one will look like this. So it would start off at 5. So it's probably not the best representation, but it would start off at 5. And it would go, the next value of 5 would be 4, and the next value of 4 would be 3, and so on and so forth. So you would start at head. So if you looked up the reverse linked list, first value would be 5. So I would think, and it says this dot next is null. So actually, I'm missing something here. So if it's at the end of the linked list, the next value will be null. So the next pointer will be null. So this will be somewhere over here. Oops. Like that. So this is how you truly know that it's reversed, because the last value will always be null. The next will be a null. So what I want to start off with, since I know the first value is going to be null, here, let me start a class. It'll be just a function that receives a node list. Okay, so reverse linked list would be like this. That's what I'm receiving. And this is the function. So
one quick question for you. So, and I'm learning some of these data structures, myself here. But is the general idea that you can go one direction in this linked list, right?
yeah.
Like when you, and so one of the things that I was exploring a little bit in the week prior was, how can I go one way through a list, but then generate, even though I'm only going one direction, the reverse of that direction?
So yeah, that's the question essentially.
Right, but what I'm saying is there are methods that we can use that will do that pretty easily for us.
Okay. So what I intend to do is go through it, the original linked list, go through it, but change the direction of the arrows. And then start off with null and change the direction of the arrows so that 1 points to null, 2 points to 1, 3 points to 2, and so on and so forth. And you can do that by starting off at the beginning with, let's go with current. So this is just like pseudocode. I don't think it actually be able to pass anything, but so the current would be null. And then the next, or actually the previous would be null. So that's going to be the first one. Current is the linked list. Like the first value. So that would be 1 right now. If I'm receiving the linked list that I put up there, that would be the first value I get. And then next will be linked list dot next, or sorry, current dot next. So the list has all the values that they have. The linked list has all the variables that this class that I'm given the list node, then I'll have a next. The next of the linked list, next of the first value of the linked list will be 2 in this situation. So the arrow will be pointing to 2. So that's what I want to change. By using previous, I could change that by storing one value in one, and then changing the other one to the other, and then moving on down the list and doing that, just reversing the arrow, basically, if you want. So what I'll do is while current exists, so it's just going to be while it's not null, because when it gets to the end, it's going to be null. I believe. let's see. So what I'm going to do is I'm going to set previous to next. Man, I can get this conceptually, but writing the code is just a different story.
Yeah, I thought it was really challenging thinking through like how to manipulate that data structure generally.
Yeah.
You know what I mean? Like if this was like a 2D array, like be pretty straightforward, you know? But I thought that was very confusing. If you have any words of wisdom as you kind of think through it, I'd love to better understand it.
If I can do it myself. So this is right here. I'm going to grab this pen real quick. So this is equal to 1 right now. And that, man, I don't even know how you wrote with this. This is equal to 2. And I want this to equal to equal null. But I want to save the 2. Okay, so I got an idea. So then current is equal to the next value. I'm gonna go ahead. I don't need 1 anymore.
Mm-hmm.
And previous is going to equal to next. Now next is going to equal to previous. That's now what the point. Next is representing the arrow. So now I'm going to have the arrow pointed to null.
Mm-hmm.
Null is previous, so it's switching the direction of that. Current's already on the 2. So now I want to move previous to current. But I already changed that. So maybe I need to do this. Oh man, this is getting me all messed up. All right, so this was 2. I don't want to change current to current dot next. This is general direction. How do you feel about that?
Yeah, I think it makes total sense. I like I said, I think you're a little bit more advanced when it comes to understanding some of these data structures than I am. One of the things I was thinking about was like if we're saying 1, 2, 3, 4 needs to become 4, 3, 2, 1, then how could we say I see 1, I hold 1, I see 2, and I push 1 down, I see 3, and I push 1 and 2 down? Do you know what I mean? Such that we're like creating a new structure such that every time we iterate over, we just put the most recent iteration in front of the last iteration. Do you know what I mean? And is there like a method to do that?
Yeah, that's what I would do if this was a regular array, but a linked list isn't an array.
So
you can't go like you can't go from 5 to 4. So once you get rid of 5, let's say you get the tail of the array,
Mm-hmm.
you can't go to 4 because 4 was pointing to 5, and that was the only direction it was going.
Mm-hmm. Mm-hmm.
So you can only go through it 1, 2, 3, 4, 5. To switch it backwards, I know what you're referring to. Like if you would do it in regular JavaScript with a regular array, you just pop and push into a new array, right?
Mm-hmm.
You pop the last value and then you push into a new array, and it would be 5, 4, 3, 2, 1.
Mm-hmm.
But because this is a linked list, you can't do that because it's not an array. It's its own separate data structure. It's more basic than an array. An array is more advanced, and it has that capability where you can pop. You could take the last value off and you could take it off, and there's no problem. It'll access it right away. But if you notice, this has a null. Like the last value would be a null, so you can't just
Mm-hmm.
pop things off of there. You have to change the
So are
next.
you thinking? So are you thinking you're gonna you store a, like I heard you said this a little bit earlier. You store a value and then compare.
You don't compare it. It's more. You see those arrows? Pretend these arrows.
So it looks like a step. That's what the way the structure looks, right? You have a value, and then you step down, and the next value is the head. You can't see my cursor here, but
You've seen that. You can see that JavaScript class, right? This is this dot next. That arrow represents this dot next.
mm-hmm.
That, so it would be 1, and then this dot next is 2. And the only way you can get from 1 to 2 is by making this dot value equals this dot next, and then this dot next equals the next one. Does that make sense to you?
Yep, it looks like this.
Yeah.
These are like it's like a Venn diagram.
Yeah, a very long Venn diagram. Yeah, that's a linked list. And so to reverse it, you can't just put one in there without taking its next value too, you know? Like if you're gonna take a value out, you have to take out its next value as well. Like that's the only thing that's pointing it to the next thing. Otherwise, it has no idea what the next thing is. If you try to go back in there, you're like, okay, well, what's the thing that comes after 1? Well, you took out 1, so you can't go to the next thing because you took out the thing that's pointing to the next one. And this is something with C. This is very prevalent in C and very basic programming, was that you need pointers. You need something that shows you what's the next thing that's going to. They're called pointers.
Mm-hmm.
They're a pain in the butt.
So with these pointers, do you know? So like with the linked list in the correct order, how can I say this? You know what it shares with 2. You know how it points to 2.
Yeah, and that's with the next.
Right. So the way that it points to 2 with the next, is that the way that 2 would point to 1 in a reverse linked list with a next?
Yeah, exactly. Which is what I'm using this previous for to store it. So it's like, okay, well, this is the previous, and I'm gonna that's the previous is gonna be the reverse the method I'm gonna use to reverse the arrow. I'm gonna store the next value there. Oh, you actually just helped me out there. So Okay, so all right. So current is 1. I change that to 2. So, okay, this is where I'm doing it wrong. I finally figured it out. I want current. I don't want to save my current there because my previous is going to be my artificial next, and my next is going to be the next in the final result in the reverse linked list. Previous is just to keep track of what's going on. So my previous will be 2. And then the current and the next will equal, Jeez, man. This is tougher than I thought. I'm going to draw this out a little bit. So I want to move node to current, previous equal current, current to next, and then next to current dot next. That's what I'm going to do. I'm not sure if that'll work, but I'll move the chains along, which is what I'm trying to do. So previous equal to current, and then current equal to next, and then next equal to current dot next now. Okay, so I think this would actually would run around through the thing and just switch. Oh, man. I think this would switch the direction of it, but I'm not sure. So I'm gonna have to ask you. Looking at the solution, is this the answer?
There's a solution in these pages.
Oh yeah. If you go.
Oh, I see a solution. Oh my God. I'm sorry, man. Total rookie league. That was a stupid question. Let me see here. That's it, man. That's it.
Is it?
I believe it is. So, let me just share with you what I have here. Did you? Let me see what you got one more time here. So you said while current. There may be one part you left out here. So while current, next node. So let me just share this with you. I was posted so you can see it in our chat. You may have left just the details of the declarations out, but while current, next node equals current next, which you've got while current, previous equals current, current.next equals previous node, next equals previous node, and previous node equals current, current equals next node. Yeah. Isn't that what you said? Just minus node?
Yeah, but it's like the order matters. So
So
um,
functionally though, how is this solution happening? Like I'm reading through this, but like what, like how, like what, what is the code that is being used to step through this data structure?
okay. So here I'm gonna look to the code. I had a pretty good idea. So okay, so previous is supposed to be null, next is supposed to be null. You just have to have the first node, which is the first linked list. This is the same thing. Instead of putting that solution, put in just one of these. Like let's say I just put on 3 or 1. I put in the whole thing and I started at the first one.
At 0, right?
So just pretend this is node. It has the same value as this. It's this dot value equals value, and then next dot next and whatever it's assigned to. I think if you can see, if you can look down, just to clarify with you, like A dot next equals B, B dot next equals C. Like that's how you chain them up. You form the Venn diagram. You can get kind of picture that in your head. So then, while current, because you only want to keep this running while you have a current, like you have a null. Because if you reach the end of the linked list, current becomes null. Okay, so if current is null, then you don't even want to add that to it. So it's not going to even keep going. It's just going to stop there. So it's going to get to 5. And you're going to have the reverse linked list. But so just to explain the parameters of the loop. And then so the next one, the next node will be current.next, because that's the next one you want to check. So it's going from 1 to 2. If you're looking at my cursor here. Can you see my cursor?
I can.
You can?
I can see your cursor, yes.
Oh, okay. So it's going from 1 to 2. So the current node is 1, and it's going to 2. It says next node is current.next, which this arrow points to 2. So it's okay. Next node is 2 because the arrow is pointing to 2. So then you change current.next, which is this arrow, because current.next, this is what this arrow is. This dot next, like you saw I had it here. You're changing it to the previous node. The previous node, if you look up there in the solution, is null. So by switching the arrow to null, you now made null the first item in the linked list, and you have 1 pointing to 2. This dot next of 1 is now null. Does that make sense? And then so the previous node, after you do that, after you got the arrow pointing there, then you make the previous node 1, and you make the current one the next node, which you made 2 earlier. That makes sense. You made current node 2 at the beginning. That was the first thing you did. And then you made the previous node 1, and the current's 2. And then you just repeat this, and you change the direction of the arrows. So 2 goes to 1, and then you switch 3, and then you make 3. The this dot next to 3 is now 2, and then you make 2 3, and then 4 3, and then you change the direction of that. Does that make sense?
It does.
And I tried doing that, but it looks like what I'm doing is previous dot null, current dot net equals next. It will just loop through it, but it won't change the direction of the arrows.
So you should have had, you said the order matters, so you should have had previous equals current, and then next equals
No, I actually had.
Or
Yeah, the order
yeah,
matters, and I never changed the arrow because you need to make it current dot next to access the value of that node to change.
okay,
You saw how you assign it in the first place down there with 8 dot next equals b. You have to do that to change the direction of the arrow, and I never did that. So
okay.
so it would just loop through, and I'd maybe have the order right, but the direction wouldn't be right. Does that make sense?
Well, it looks like your it looks like previous. It does make sense, but it looks like because it says store reference to the next list node, right? And that's next node, which is will be the head of the next full node equals current dot next. Reverse the next pointer, current dot next equals previous node. Man, this is a real mind bender here. Previous node equals current. Got it. Current dot next equals previous node. That's what you're saying you needed in order to actually reverse the direction of the list.
Yeah.
Or
Otherwise,
excuse me, not direction of the list, the direction of the pointer.
yeah, which is the direction because it's better to think, oh, like why the hell would you ever need this if you have arrays? Imagine that these numbers are just floating out in memory. Like they have no relation to each other. Let's just say they're random numbers floating out to but or like in the memory. Like it's just part stored there. So in order to know that these are all related to each other, you need something that points to the other one.
Got it.
And that's the order that would be. The order that you point, this one points to that one points to that one points to the other. That's how you know that's the array 0, 1, 2, 3, 4. But you only know that because they're pointing to each other. Otherwise, they're just a random sort of numbers. And I might be wrong about this, but I'm sure this is already built into like modern languages, arrays. Like you would never actually have to use this. There's some things, some concepts or some problems you might run across where it'd be useful to do, but I believe anything anything a linked list could do, an array already has it built in.
Well, a linked list would basically be like two tables with a foreign key, right? Share like a foreign key being issued by one table and referenced by another one. No, what? No, it wouldn't because
If each one was its own table.
if each one was its own table. So
Yeah,
this is yeah, interesting. So this is actually this concept of having a pointer to the next body, to the next body of data, right?
yeah.
Um,
This is all C. This is you can go through computer science and the computer science curriculum, and you're gonna see just how great Python and JavaScript is.
That's awesome, dude. That's awesome. Well, it looks like we have like a minute left.
Yeah.
But
So,
man, Kevin, I really, really appreciate you being patient with me, man.
of course, man, it was great. It was a learning experience for both of us, man.
Yeah, I really appreciate it, dude. So, is there any follow up that needs to happen on after this?